Welcome to the MassDOT Intersection Control Evaluation, or ICE computer-based training. This training module is one of 5 modules for the ICE procedure, and it will cover ICE Stage 1, Purpose and Overview. Module 2 of this training series will go in-depth on applying ICE Stage 1 in case scenarios. At the conclusion of this training, you will understand the answers to the following questions. What is ICE? Why does MassDOT use ICE? When is ICE applicable? What are the intersection control strategies? What resources are available for completing ICE Stage 1? What is the outcome of ICE Stage 1? The first training goal to cover is, what is ICE? ICE is a 3-stage approach to evaluate, compare, and select a preferred intersection control strategy. The 3 stages are Stage 1, Screening, Stage 2, Initial Assessment, and Stage 3, Detailed Assessment. The control strategies that can be analyzed include traffic signals, two-way and all-way stop control, roundabouts, displaced left turns or DLT, quadrant roadway, median U-turn or MUT, signalized and unsignalized restricted crossing U-turn or R-cut, continuous green T, and jug handle. When considering use of a MUT or DLT, note that the control may look different for different approaches. Approaches need not match. ICE considers each strategy's potential safety impacts, operational impacts, and multimodal factors. The result of the ICE procedure is a lifecycle cost for each viable control strategy. The lifecycle cost factors include construction and maintenance costs, right-of-way costs, vehicle delay, and safety. Before continuing the training, consider scanning the QR code on the left of the slide using your phone camera, which directs you to the MassDOT ICE webpage. As previously mentioned, ICE consists of the following 3 stages to evaluate, compare, and select a preferred intersection control strategy. Stage 1, Screening. Stage 2, Initial Assessment. Stage 3, Detailed Assessment. This training module will focus on Stage 1, Screening. The next training goal to cover is, why does MassDOT use ICE? The primary purpose of an intersection control evaluation, or ICE, is to provide a consistent methodology to compare multiple intersection control strategies and select a preferred control strategy when planning a new intersection or modifying an existing intersection. The main goal of the preferred control strategy is to provide the overall long-term best value while providing safe travel facilities for all road users. While considering the intersection's context and roadway classification, the ICE procedure is used to objectively evaluate, compare, and select a preferred intersection control strategy to meet the project's purpose and need. The ICE procedure is intended to provide a consistent comparative analysis for all control strategies. Designers will consider multiple intersection control strategies, allowing a comparative decision-making process to select a preferred control strategy. The decision to select a specific control strategy is documented through the ICE process. The next training goal to cover is, when is ICE applicable? This is an overview of the form used to determine project and intersection level applicability of the ICE process. Step 1 asks questions on the project level, and Step 2 asks questions of each project intersection. If the project is being initiated through the MAPIT system, note in your application that ICE is not required. The first sections to complete on the form are project information and questions about project level applicability. Be sure to download the ICE forms from the MassDOT website so any recent updates will be captured. There are 3 conditions that determine if a project is exempt from the ICE procedure. A project is exempt from the ICE procedure if any of the following 3 conditions apply. The first condition is that a project is exempt from the ICE procedure if all of the following are true. The project is municipally led, entirely on locally maintained roadways, not funded using Federal Highway Administration funds, not being designed by MassDOT or MassDOT consultants, not advertised by MassDOT, and not included in a Category 2 or 3 access permit. The second condition is that a project is exempt from the ICE procedure if the project is fully funded through Chapter 90 or a MassDOT grant program and is entirely on locally maintained roadways. The third condition is that a project is exempt from the ICE procedure if the project receives a written waiver from the state traffic engineer. When all the questions are answered, instructions will appear saying either that ICE is not required, no further evaluation needed, or proceed to step 2. The next section to complete includes questions specific to each intersection. The first 2 questions determine if an intersection is exempt from ICE. The questions are: do all minor street approaches to the intersection have an AADT less than 1,000 vehicles per day? Did the intersection receive a written waiver from the state traffic engineer? If either answer is yes, ICE is not required. Traffic volume data sources are linked later in the training. The next set of questions determine applicability for ICE at each intersection. The first 3 questions in this section are: is this a new intersection being created? Are any approach or departure legs being added to the intersection? Are any through, left turn, channelized turn, or bypass lanes being added to the intersection? If any of the answers are yes, ICE is applicable to the intersection, and it will move to stage 1. It is important to note that the reallocation of lanes on an approach within the existing pavement does not trigger ICE. There are 3 more questions which determine applicability for ICE at each intersection. They are: is the traffic control at part or all of the intersection changing, adding or removing signal, stop, or yield control? Does the intersection include full-depth pavement reconstruction on a National Highway System roadway? Is the intersection a high crash location except when the scope of work is limited to maintenance or resurfacing? If any of the answers are yes, ICE is applicable to the intersection and it will move to stage 1. High crash locations are defined as an intersection within a cluster for the most recent period shown on the MassDOT Interactive Crash Cluster Map. This map is linked later in this training. If an intersection is a ramp terminal or rotary, contact the MassDOT Traffic Safety Group at the email listed to determine whether the location is a high crash location or not. If a written waiver for the project or a specific intersection is being requested, an email shall be sent to the state traffic engineer and the traffic safety group with the following: a summary of project information, including the MassDOT project or permit number, if known. Describe if the waiver request is for a specific intersection or the entire project. If the waiver is for the entire project, project limits shall be specified. If the waiver is for individual intersections, the intersections shall be specified. Include a narrative describing the reasons for the waiver. Include any supporting analysis, such as traffic volumes, if available. The next training goal to cover is: what are the intersection control strategies? Stage 1 is a high-level viability screening of intersection control strategies. These strategies include two-way stop control, all-way stop control, signalized control, roundabout, unsignalized restricted crossing U-turn, R-cut, signalized restricted crossing U-turn, R-cut, median U-turn, MUT, or partial median U-turn, PMUT, continuous green T, displaced left turn, quadrant roadway, jug handle. The Stage 1 results are summarized in the ICE Stage 1 form and are submitted to the project manager prior to the project scoping meeting. At this stage, the intersection control strategies are evaluated against the project goals and objectives based on available data. The screening involves planning level evaluations, which will be discussed next. Note that not all intersection approaches must use the same control strategy. For example, left turns may be displaced for just one or two approaches or all four. The ICE process is meant to assess how well different intersection types may fit each project intersection. More information about intersection types can be found using these resource links from the Federal Highway Administration. This training will also cover some basic movements for the intersection types. The next training goal to cover is what resources are available for completing ICE Stage 1. The study location should be evaluated using readily available data. Traffic data collection is not required in Stage 1 and need not be conducted before project scoping. The study intersection should be reviewed at a minimum using aerial photography and online map imagery. A field review is not required but could be helpful to establish the adjacent terrain topography, land uses, visible utilities, structures, and potentially sensitive environmental areas. MassDOT and other available data resources, such as the project initiation form from MAPIT, should be utilized to evaluate a location. The MS2 web portal provides access to historical traffic volume data. The link is shown here. The GeoDOT web portal includes a wide range of maps and data sets related to the transportation network. Available data includes roadway characteristics, top crash locations, bicycle facilities inventory, links to roadway layout plans, and many more details. The link to GeoDOT is shown here. The high crash location map from MassDOT provides a visual representation of high crash locations for use in answering the applicability question. Use these portals as a first stop in collecting and reviewing existing roadway data. It is important to note that these data sets are not accurate enough to be relied upon for design and will need to be verified using other methods. The MassMapper web portal provides online data from the Executive Office of Energy and Environmental Affairs. Use this portal to review data about sensitive environmental areas. Next, we will discuss how this information feeds into the analysis. FHWA's CapEx tool is optional. The tool can only be used in Stage 1 if traffic volumes are available. If volume data are available, it is recommended to use CapEx in ICE Stage 1 to help evaluate the viability of each control strategy. CapEx develops a planning level volume to capacity ratio to compare control strategies. CapEx can be used if the following data are already available: turning movement counts and truck percentages, as well as roadway characteristics information. Links to the CapEx tool and user guide are provided on the slide. Note that this data is not required to complete Stage 1, but if it is available, then CapEx can be used. A safety analysis is optional in Stage 1 and is only encouraged when crash data is available. A full safety analysis is required in Stage 2. To complete a safety evaluation, it is recommended to use the MassDOT Safety Alternatives Analysis Guide. The guide is designed for engineers, planners, and analysts at the project level to assist with the data-driven approach. The methods and tools within the Safety Alternatives Analysis Guide provide insight into the potential design and traffic decision effects these will have on roadway safety. For a detailed how-to guide on safety evaluation, refer to the Stage 2 modules of this training series. The next training goal to cover is, what is the outcome of ICE Stage 1? To answer this, we will walk through the Stage 1 form and questions. Once the resources have been reviewed and analysis is complete, the ICE Stage 1 form should be filled out to document the viability of each control strategy or the exclusion of non-viable control strategies. ICE Stage 1 form summarizes the evaluation performed at this stage. The key outcome is a list of viable intersection control strategies as highlighted with the colored box in the form. Please note that the project proponent should add a brief note to explain why some control strategies are or are not viable in the cells to the right. The justification box should not be used to reiterate information already provided on the form. The project proponent should start by completing the project information at the top of the form, including the project setting, project need opportunity, and multimodal context. Use these project attributes to answer how each viable control strategy fits into the context of the project. Be sure to download the ICE forms from the MassDOT website so any recent updates will be captured. It is important to note that the example on the screen may not perfectly match the latest version of the ICE forms. The project proponent should select an answer from the Yes/No drop-down menu. Project proponents should use context questions to help determine if a strategy is viable. Provide a brief note that explains why some control strategies are or are not viable. The first question on the ICE Stage 1 form reads, could the control strategy address the project need in a balanced manner and in scale with the project? For example, suppose the original project need is to add a left turn lane at a signalized intersection. In that case, constructing a displaced left turn on all intersection approaches may be considered out of scale. Some potential fatal flaws to consider when answering this question could include the following. Traffic volumes or adjacent land uses clearly do not warrant installing a traffic signal. The connecting roadway does not support the design features of a control strategy. For example, generally undivided roadways will not support median U-turns. The second question on the ICE Stage 1 form reads, could the control strategy improve safety performance in terms of reducing severe crashes? To answer this question, consider historical crash data from the MassDOT Impact Portal and consider the crash types impacted by each control strategy. For example, suppose an intersection has an existing issue with angled crashes. In that case, a roundabout will likely reduce the number of severe crashes occurring, even if the number of PDO crashes increases. Proponents can also review the fatal and injury-related crash modification factors, FI/CMF, listed in the MassDOT Safety Alternatives Analysis Spreadsheet tool. The third question on the ICE Stage 1 form reads, could the control strategy incorporate safety, convenience, and accessibility for pedestrians and/or cyclists? For example, a location with high pedestrian traffic may not benefit from a displaced left turn, as this may increase the number of required crossings. A control strategy could be fatally flawed if it does not include design elements that provide the same level of safety, i.e. separation, or connectivity as currently available or proposed for the adjacent street network. The fourth question on the ICE Stage 1 form reads, could the control strategy improve or preserve traffic operations such as congestion, delay, or reliability? This question can be answered using CAPX to obtain planning-level operational results if traffic counts data is available. If data is unavailable, consider the current anecdotal congestion observations or nearby traffic volumes. Locations with low traffic activity are less likely to warrant the installation of or benefit from a traffic signal. Existing intersections with warranted traffic signals are often less likely to operate acceptably with control strategies that use stop-controlled movements. The fifth question on the ICE Stage 1 form reads, could the control strategy appear viable given the site constraints and location context? For example, a median U-turn is not viable at a location with no median and no space to construct one. A control strategy could be fatally flawed if the right-of-way acquisition is not proportional to the project's purpose and need. Acquiring right-of-way for a control strategy is not necessarily a fatal flaw. The sixth question on the I-Stage 1 form reads, could the control strategy appear viable concerning other project factors? For example, consider environmental and utility impacts. A control strategy could be fatally flawed if it impacts multiple features on 3 or more intersection quadrants, leaving little chance of design around them. Module 2 of this training series provides further context using a case study to answer these questions. The last question on the I-Stage 1 form reads, is the control strategy viable? Review the available data in the context of the previous 6 questions to identify and document existing fatal flaws with the control strategy's implementation. A strategy may be viable even if the answer is no to one or more of the previous 6 questions. Stage 1 is intended to be an initial screening, not an in-depth analysis. The goal is to determine if a fatal flaw is known from the beginning before advancing to Stage 2. If a scope of work has been developed, consider the scope elements and the control strategy being evaluated. For example, if the existing intersection includes 4 legs, the continuous green T is not viable. Additionally, if the existing control type is a signalized intersection and the signal is warranted, it would be reasonable to assume two-way stop control, all-way stop control, and unsignalized R-cut are not viable control strategies. The existing conditions information can be reviewed with operations and safety evaluations to consider whether each control strategy is viable. If the Stage 1 analysis results in only one viable control strategy and MassDOT approves the analysis, the ICE procedure is complete. If Stage 1 results in multiple viable control strategies, Stage 2 is required. The project designer should scope these additional activities and the project development work tasks. Module 3 of this training series provides a detailed Stage 2 process description. ICE should be included in the work tasks. Note that it is expected only a few control strategies will move into Stage 2 based on the project site context. Stage 3 is not typically anticipated or included in the pre-25% design scope of work. But if Stage 3 is needed, it should be completed during the pre-25% design work. Take a moment to reflect on what you've learned. In this training, we've covered, what is ICE? Why does MassDOT use ICE? When is ICE applicable? What are the intersection control strategies? What resources are available for completing ICE Stage 1? What is the outcome of ICE Stage 1? Thank you for watching Module 1, ICE Stage 1 Purpose and Overview.